Okay, so welcome back to calculus, where we are treating differentiation. And in differentiation, we'll be looking at product rule. So, and there is a question ahead of us. You know, in our previous video, we talked about product rule and is value boosting that we use. So, in this part, let's look at example 1. It said differentiate the following with respect to x. Differentiate the following with respect to x. So, question 1, we have this. Question 2, we have this. So, I'm solving this number 1. Then, you will solve number 2 and drop your answer under the comment section. So, now let me just solve. How can we solve this? I will say solution. Solution. So, in this, question 1 is x cubed plus 2 and x is power 4 plus 2x. So, this is the question in our front. So, that is y is equals to this. So, let's recall what does product rule state. It states that if y is equals to uv, then dy dx equals to v du dx plus u dv dx. This is what product rule is talking about. This is what product rule is talking about. So, at this junction, I will say this is my u, this is my v. So, I can say let u equals to this, which is x cubed plus 2, and when you have let your u to be this, then we have the u dx will be equals to differentiate x cubed. It will become 3x squared. When you differentiate ordinary 2, it will become 0. Why? Because the rule says that if y equals to c, then the y dx equals to what? 0. Why? Because there is no coefficient of x, no x beside this ordinary alphabet. So now there is no x beside these two, so automatically it is 0. It is 0. So, and again, we can now say let v equals to this, x raised power 4 plus 2x. Then the v dx equals to differentiate x raised power 4. We have 4x raised power 3 plus, when differentiate 2x, we have 2. Don't forget, I'm applying the formula that says that if y is equals to x raised power n, then dy dx will be equals to anx n minus 1. So don't forget, general formula. If you watch the first video, you will see this general formula is what I am applying to get all these values. So since I have noted my u and du dx, v dv dx, then I can come back to the formula that says that dy dx equals to v du dx plus u dv dx. So I will now say dy dx equals to, what is v? V, this is v. V is x is power 4 plus 2x, close brackets, that is v. Then in calculus, we don't use times, multiplication times. That's your times, we don't use it here, we only use points to represent times. So du dx is what? Du dx is 3x squared. Du dx is 3x squared. Then we now have plus u. What's u? U is, open bracket, x cubed plus 2 close bracket dv dx. Dv dx is 4x cubed plus 2. That is the VDX. So when we multiply them together, we have the y, the x equals to 3x squared times x raised to power 4 will give us 3x raised to power 6. 3x squared times x raised to power 4 will give us 3x raised to power 6 plus this same 3x squared times 2x will give us 6x cubed. Yes, plus x raised to power 3 times 4x raised to power 3 will give us 4x raised to power 6 plus this same x raised to power 3 times 2 will give us 2x raised to power 3. 2 times 4x raised to power 3 will become plus 8x raised to power 3. Then this 2 again times this 2 will give us plus 4. So that is the expansion. That is the expansion. So by taking the highest coefficients together, I will say the y, the x equals to, as you can see, we have 3x raised to power 6 here plus 4x raised to power 6, the highest coefficients, then followed by plus 6x raised to power 3 plus 2x raised to power 3 plus 8x raised to power 3 plus ordinary number, which is 4. So I can say the y, the x equals to, add these two together since they are having same coefficient of x raised to power 6, x raised to power 6. Add it together, we have what? 7x raised to power 6 plus this plus this will give us 16x raised to power 3 plus 4. Final answer. So that is the final answer.